Okay. Example 5, find the limit of each. So we're going to draw the graph of y equals sine of x, y equals e to the x, and y equals the natural log of x to help answer these questions. Okay? So first of all, let's graph y equals sine of x. So this should be a very familiar graph to you that you should be able to graph easily. Graphing will be really important in this class. So if you need to brush up on graphing, make sure you do so, because it will be definitely will determine how successful you'll be in this class. So there is y equals sine of x. Next, let's graph y equals e to the x. All right. So if we start with a table, let's start with 0. E, if you remember, E is roughly 2.718, kind of like pi. It's an irrational number. So if it's e to the 0 power, that's going to be 1. So we're going to have a point at 0, 1. Next, let's do 1. So this would roughly be 2.718, which again is roughly e. So 1, 2. So that's going to be roughly here. Okay. If I pick -1, that's going to be e to the negative first, which is 1 over e. Okay, so that's going to be a decimal, so it's going to go this way. So if we kept plotting points, the graph of this function is an exponential function, which would look like this. Should be familiar. Okay, now let's graph. So let's put this here. Y equals, let's call this f of x. F of x equals e to the x. Now let's graph g of x equals the natural log of x. Okay, so now let's graph g of x equals natural log of x. So again, this should be a graph that we're familiar with, but let's go through it. So, okay, something else to think about, that these graphs, there's an inverse relationship here. So if we look at this ordered pair, the domain of this function will be the range of this function. And the range of this function will be the domain of this function. So we know we have a point at 1, 0. Okay. Also, right here, the domain of this function will be the range of this function, and the range of this function will be the domain here. So now let's graph these points. So we got a point at 1, 0. and we have another point at 2.718, 1. Okay, so this function is going to look like this. Okay, and hopefully you can see the inverse relationship here, where these two functions, they reflect the line y equals x. Okay. All right, so now let's use these graphs to figure out these answers. So the first one, part A, we have the limit of sine x squared. I'm going to write it this way, as x approaches 0. So let's see if direct substitution would work. If I plug 0 into sine of x right here, I'm going to get 0, right? So if I try this, sine of 0 would be 0. 0 squared would be 0. So that's going to be 0. That works. Next, let's try the limit of x times e of x as x approaches negative 1. Okay? Well, we know if the only graph that we don't have up here would be the graph of the function x, y equals x. Okay? So we know if we plug negative 1 into this function, okay, as x approaches negative 1, that's going to be negative 1. And then e to the x, if you plug negative 1 into that, that's going to be e to the negative first. So if we simplify this, this would be negative 1 over e. We can do direct substitution there. Okay, and then finally part C, I got the limit of the natural log of x cubed as x approaches e. Okay, so again, now I'm looking at this function here. Okay, so first of all, let's try direct sub. Let's do g of 3. Well, let's do this. Let's rewrite this as the limit of 3 natural log x as x equals e. That's a property for exponents. And now let's try direct substitution. Let's do g of e equals the natural log of e, which would be 1. Okay? So if I do direct substitution, if I take this e and plug it in for this x, this whole thing would become 1. 1 times 3 is 3.